Hello, so here we see an output characteristics of a bipolar junction transistor. So it's a characteristics between the current on the y-axis and the voltage on the x-axis. So the current on the y-axis is a collector current and the voltage on the x-axis is the voltage across collector and the base region of the transistor. So as you can see on the y-axis, the current ranges from 0 milliampere up to 7 milliampere, and on the x-axis your voltage ranges from 0 volts to up to 20 volts. So now when your bipolar junction transistor, we are talking about NPN transistor as an example, both the junctions are reverse bias, then the BJT is said to be operated in the cutoff region. When both the junctions, that is the base emitter junction and the base collector junction, operate in the forward bias mode, that region is called as saturation region. And when the base emitter junction is forward bias and the base collector junction is reverse bias, the BJT is said to be operated in the active region as shown by the green lines. So in the cutoff region, the output current is essentially zero, as you can see. In the saturation region, the output current is quite large. Even with the slight increase in the VCB, you see a large variation in the output current. And in the active region, which is an unshaded area right here, you can see that it is written here, the current is constant for each value of the input current, that is IE. So for I equal to 0 milliampere, current is 0. I equal to 1 milliampere, the current is 1, output current IC is 1 milliampere. I equal to 2 milliampere, the output current is constant 2 milliampere, so and so on. So this happens when you have NPN transistor biased in the active region, where its base emitter junction is forward bias and collector base junction is reverse bias.